first one, nature. Is it arithmetic, geometric, or neither? I'm adding a 3 each time. So the nature of this sequence is arithmetic. I would argue it's probably easier to get the next 3 terms next. We're just adding 3. Keep adding 3. Since it's an arithmetic sequence, that means my rule is going to look like this. My a to the 1 is 5, and my d is 3. A to the n equals 5 plus 3n minus 3, and a to the n is 3n plus 2. And that's our rule. Here I'm multiplying every one of these by 1/2. So that's the definition of a geometric sequence. The next 3 terms, 12 times 1/2 is 6, 6 times 1/2 is 3, and 3 times 1/2 is 3/2. The rule, since it's geometric, n equals 96 is my first term, my rate is 1/2, and it's always raised to the n minus 1. So when they want the rule, 96 times 1/2 raised to the n minus 1. That is your rule. Even though it's a fraction, we're literally subtracting 1/3 each time. That's the definition of arithmetic. The next 3 terms, I'm just going to keep subtracting 1/3. I'm going to say -1, -4/3, and -5/3. I don't write -3 over 3. I'm going to translate that into 1. My rule, same deal. A to the n, my a to the 1 is 1/3 plus n minus 1 times, we're doing a -1/3 here. So a to the n equals 1/3 minus 1/3 n plus 1/3. So we would argue -1/3 n, 1/3 and 1/3 is 2/3. And that's my rule. It's -1/3 n plus 2/3. So in this problem here, it's not geometric, it's not arithmetic, so we'll write neither. The next 3 terms, I added 7, I added 9, I added 11. So by that pattern, I'm going to add 13, I'm going to add 15, and I'm going to add 17. So it's 50, 65, and 82. And those numbers continue to be 1 more than a perfect square. My rule, n plus 2, gets me to that my first perfect square. N plus 2, 1 plus 2 is 3, 3 squared is 9, plus 1 gives me 10. If I plug my second term in, 2 plus 2 is 4, 4 squared plus 1 is 17. If I plug my third term in, 3 plus 2 is 5, 5 squared plus 1 is 26, and that's my rule. The last one goes back to something a little more basic. We're multiplying each of these by -3. You do have to change that. I put 144, it should have been 108. Okay. The nature here, because we're multiplying, geometric. We probably need to go to a calculator for the next 3 terms. So I'm going to go 108 times 3, or -3, we get 324. Multiply by another 3, we get -972. Multiply by another 3, we get 2,916. Those are your next 3 terms. Since it's a geometric mean, 4, -3 to the n minus 1. That's what your a to the n is going to equal. So my rule, 4 to the -3 times n minus 1. And that's my answer. All right, so AN equals A1 plus N minus 1 times D. That's what I'm going to write each time. My A1 is 7. My D here is 5. So I'm going to come up with my rule first. 7 plus 5N minus 5. 5N plus 2. That's the rule. If I want A28, the 28th term in this sequence, well, 28 times 2 is 140. 140 plus 2, that's 142. Now, if you want to check your work, the 4th term is 22. Check it. 5 times 4 is 20 plus 2 is 22. All right? You can always check your own work. Here, A to the N equals A1 plus N minus 1 times D. I don't have my A1, but A7 is 15. So I've got to get my sorry about that. My D is going to be a negative 4. So 15 equals A1. 6 times negative 4, we subtract 24. I'm going to add 24 on both sides, and I get 39. That's my A1. So now, A to the N equals 39 plus N minus 1 times a negative 4. 39 minus 4N plus 4. And A to the N equals negative 4N plus 43. And that's your rule. When I do my A28, negative 4 times 28 plus 43. So when we do that one, we're going to get negative 4 times 28, which I believe is negative 112. Negative 112 plus 43. And we're going to get an answer of negative 69. So there's our answer. Here's our rule. This, so we get the extra practice with it, a little more involved here. Here, because you're given 2 points in the sequence, that's not the first one, you've got to get your D, then you get your A1. So the D is gotten by basically doing a slope. 98 minus 14, 20 minus 6. And that's going to give me 84 over 14, which is 6. Okay? Now, I don't care which point you pick. I'm going to go with that one because it's smaller. 14 equals a to the 1 plus 6 minus 1 times 6. 14 equals a to the 1 plus 30. 6 minus 1 is 5. 5 times 6 is 30. We subtract the 30 and we get negative 16. There's my A1. So now I got to go to the rule. I have an A1 of negative 16 and a D of 6. So negative 16 plus N minus 1 times 6. A to the N equals negative 16 plus 6N minus 6. A to the N equals 6N minus 22. That's the rule. That's an answer. And then A to the 28 equals 6 times 28 minus 22. So 6 times 28 is, if I'm not mistaken, 168. But I do want to check it. Yeah, 168 minus 22. And we end up with 146. And that's our answer. Second one, negative 10 minus 30. 15 minus 7 is negative 40 over 8, which is negative 5. I'm going to use 7 and 30. 30 equals a to the 1. Oops. Sorry about that. plus 7 minus 1 times a negative 5. So in this case here, 30 equals A1 minus 30. I'm going to add 30 to both sides and get 60. So now, A to the n equals 60 plus n minus 1 times a negative 5. Those signs do matter. AN equals 60 minus 5n plus 5. So A to the n equals negative 5n plus 65. Okay? And then we're going to plug these, that's our rule, 28 in for n. Negative 5 times 28 equals 65. Oops, need that. Check that. All right, negative 5 times 28, I'm guessing negative 140, but check. Yeah. Negative 140 plus 65. My A28 is negative 75. And there's your answer. The n term here is always going to be the number up top minus that first term I is equal to plus 1. So my n term for this is going to be 14. My A1, 4 times 1 is 4 plus 3 is 7. My 14th term, or my last term, 4 times 14 is 56 plus 3 is 59. And now we're just plugging into the formula. Okay? So we get 14 over 2 times 7 plus 59. 14 over 2 is 7. 7 and 59 is 66. So our sum is going to be 66 times 7. So that sum is 462. $20 minus 5 plus 1. That means my n is going to be 16. I'm starting with my 5 though. So my A first term, 3 times 5 is 15. 15 minus 7 is 8. My 16th term, which I'm putting 20 in for the I, 3 times 20 is 60, minus 7 is 53. So now, 16 over 2 times 53 plus 8. That's 8 times 61. And when I do 8 times 61, we get a sum of 488.